Hey guys, so let's do a video where we just talk about hydrogen bonding. So we're going to do a problem from the homework for my CHEM101 students or anybody who needs some practice with this. And remember, I abbreviate IMF is the intermolecular force. So remember, we're trying to figure out which one has hydrogen bonding. So below here, I made a little note. Let's talk about what the rule of NOF is. You have to have a hydrogen, so hydrogen has to be bound to either NO or F in the molecule, right? So let's check these guys out if we are satisfying that requirement. And just as a bonus, we can also talk about which forces we see. So for this first compound, H2S, we see that the hydrogen's only bound to a sulfur, so it can't be hydrogen bonding, right? So I'm going to say no. I'm going to just maybe make it thick so I know I addressed it. So that's a no. I'm not going to fill that in. But what does it have? It seems like it has a dipole moment, right? So we can make a note for that. The strongest force here involved is a dipole moment. So strongest is dipole. Why? Because this would be partially negative, this would be partially positive, partially negative, so we'd have a negative kind of dipole going up that way. So we're just doing some extra practice with intermolecular forces here. Next, let's move over here. We have carbon bound to hydrogen, 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 carbon bound to oxygen, and oxygen bound to hydrogen. Whoop, there it is. This, a hydrogen and an oxygen bound. This passes from rule of NOF, N-O or F. So right here is why we're going to fill this bad boy in. So that is a yes. Let's go down here just for fun. So I don't see any place where H is bound to an NO or F. Do you? So carbons are the only things that are bound to hydrogens. So this is no hydrogen bonding. What about dipole-dipole, which is the next strongest? I do not see anywhere where I can mark this as slightly positive or negative. In the previous video I talk about if a compound is just C's and H's, nothing else is in there, just C's and H's, it's going to be dispersion forces. Those are the strongest. So the strongest is dispersion. So I'm going to outline this again just so that we double check our work so we don't lose track, but that's an absolute no. I'm not going to be filling that in. Let's go right here. So carbons are bound to hydrogens, no help there, carbon bound to nitrogen, but nitrogen is bound here to what? Hydrogens. So this will, because of these bonds here, this is why we're going to call this hydrogen bonding, because it does have nitrogen bound to, or sorry, hydrogen bound to NO or F. So I'm going to go ahead and fill this bad boy in because he's a yes. How about down here? We have a carbons bound to hydrogens, right? And then a fluorine bound to a carbon. I do not see anywhere where there is a hydrogen bound to a NO or F. There's a hydrogen and an F in the same compound, but that does not pass the rule of NOF. H has to be bound directly to F. So this does not have hydrogen bonding. However, does this have dipole-dipole, which is the next strongest? Yes, it does, because the F would be partially negative. Remember how negative fluorine is? And all these hydrogens would be slightly positive. So this would have a dipole moment. So the strongest is, the strongest is dipole-dipole. So these are the only two that are demonstrating hydrogen bonding, which is the strongest. These two are demonstrating dipole-dipole. And this one down here is demonstrating only dispersion as its strongest force. So I hope that this helps you guys practice. On an exam, I would most likely draw some of these out so that you can visually see it, so that you're not tricked. All right.